Well, today I kind of structured broadly about how to be a space advocate. I'm also going to kind of encourage you, particularly as graduate students and other folks in academia, future graduate students, why this is something you might want to really incorporate into your kind of role or portfolio of responsibilities. Whether that's fair or not, we can talk about that, but it's something that I think that's really important for this incoming and future generations of scientists and professionals to be a part of this process, because in a sense, your whole future depends on, right now, public funding for science and research, which I assume you'd all like to have jobs in this, and this is a kind of a direct way to do that. Brittany already kind of gave a good overview of the Planetary Society. I'll just really emphasize one thing, which is that we don't receive our significant amounts of money from the corporate sector. We don't take money from aerospace companies, and we don't take money from the government. And so when we talk about kind of our goals in space policy and goals in space politics, we don't have a skin in the game. We don't have conflicts in this. This is really rare in the realm of people who operate in kind of outreach and education to Congress, that we are really representing the people who pay to be members of the Planetary Society, our members themselves, and there's no other organization of this size and scope that can do that. So I love to emphasize our independence in this. I'm not taking checks from Boeing or Lockheed or whatever to promote a certain perspective. And again, just to mention, our three real areas of interest for the organization, our formal areas of interest, are going to be planetary defense in terms of protecting us from neo-collisions, exploring, basically planetary exploration, right? Planetary, it's in our name, and search for life is a big kind of overall aspect of what we like to do. So that's kind of our background. So I always like to really emphasize here too, that space policy and advocacy, tons of opportunities, lots of ways to really make a difference in this particular field for a number of, in a sense, kind of unique reasons that we don't have in a lot of other areas of politics. So if you've looked at politics over the years and say it seems cynical or nothing ever happens or really frustrating or just goes back and forth, we don't really have those problems in the area of space. And that's rare and a huge opportunity, really exciting area to really be involved in. And I'll get to why that is. So we have these following advantages when we're talking about space really broadly right now. And we can talk about space science in particular later, or ask me questions about it. But first, space is non-ideological, right? So there's no Republican or Democratic party platform that are distinct about what the party should be, I think the United States should be doing in space, right? There's no profound ideological grounding that prevents compromise or reacts to each other. And that's a really rare, increasingly rare thing. And that may, it's starting to seep in at the edges, right? Climate change and earth science is starting to be one of those areas in space where this has already happened. But for the most part, space exploration is non-ideological. So when things are non-ideological, you have kind of this old school style of like Mr. Smith Goes to Washington politics, where persuasion and parochial interests really dominate the decision process of how coalitions are formed to support various aspects of space exploration. Again, with that, it's nonpartisan. People generally feel good about it, right? You look at poll after poll, people like space. I wouldn't say the support is really profoundly deep for space exploration, but we just saw with the landing of the Perseverance rover last week, huge amount of interest and positive interest. It just looks cool, right? It's got that overall like, yeah, NASA did us proud kind of a feeling. That's a great opportunity, right, to build off of that general positive response. And kind of related to this, there's no organized opposition against space efforts, right? There's no anti-NASA coalition lobbying Congress every single day to shut down NASA. And again, we can't take that for granted. We kind of do, but almost every other issue that we deal with in politics has some sort of like anti-version of it, right? Or competitive version for it. And so this is a huge set of opportunities, really, right? That we don't have these profound ideological barriers. We don't have anti-NASA or anti-space investment groups working every day against this type of thing. And so it's really, in a sense, the types of advances we're able to make in space exploration at a political level are a function in a sense of how well pro-space people can kind of engage on the issue and really push forward in a coherent in-phase way. Obviously, there are some disadvantages too, and we should acknowledge those. It is at the same time that it's a weak ideological trigger is a positive. It's not. It helps. Without that, I guess it doesn't raise to the top level thinking of most politicians, right? So because it's not a hot button political issue, because people don't see their votes entwined in political futures dependent upon space as a political issue, it's hard to get attention, right? So it's hard to develop action at a political level because of that. The lobbying that is done on space, absolutely dominated by organizations that do have skin in the game, right? People who have contracts on the line, aerospace companies from Lockheed to SpaceX, down to even the universities all have federal representatives trying to encourage university perspectives in terms of how they write grants and things. And so there's an industry dominated by the people who tend to financially benefit from it in terms of the political discussion. And they have the money in a sense to really be out there every day. Politically, just really stepping back, right? Things in space take a while to pull off. As we saw with the Perseverance rover, that mission was announced publicly in December of 2012, entered phase A in 2013, and obviously just landed on Mars a week ago, right? So that's almost 9 years from start to finish. And that's through 3 presidential administrations and up to roughly 4 or 5 Congresses. So how do you maintain political support in this kind of disruptive political environment? And then, of course, at the public level, space can be really abstract, right? You couldn't choose a more literally out there thing to be talking about that's not in their immediate sphere of experience. And even though you can get really broad positive responses to the idea of space, when presented with choices about what the government should be investing in, the priority of space tends to be low. We actually just saw this, I think it was 2 days ago, yesterday, through a recent Morning Consult poll that came out and showed that I think space was 25th out of 26 priorities as rated by the public for the incoming Biden administration. These are the disadvantages that we have, right? None of these are insurmountable, but we should be really honest about, how we frame this issue. And I personally think the opportunities and the advantages offered by space in terms of a political advocacy perspective outweigh these disadvantages. And let's just kind of talk about maybe the fundamental problem of space, right? In terms of, and particularly from our perspective as, scientists and space scientists, that it's not too complicated, right? Like, we have a lot of great ideas. The universe is really big. We want to go to a lot of places. And the budgets that we have to support that cannot do everything. And, and really the budgets are actually truly modest, if not very small, compared to the set of opportunities and ideas and possibilities that we could be doing, right? A lot of you know this. This is a classic projection of NASA's budget over the years. This is actually this is what the White House has requested. We can talk about, there's an interplay between how the budget ultimately gets set. The White House proposes a NASA budget and Congress ultimately takes that and provides the money at the end of it. Those two can differ, but it's actually, if you really plot one against the other, it's pretty close. Like, frankly, the White House and the initial policy proposal tends to be a very strong driver of the ultimate outcome of the money that NASA gets at the end of the day. And this is similar for the National Science Foundation for people who take money from that, get grants from National Science Foundation or NIH or any other kind of government federal research agency. So again, classic NASA budget history that we're looking here through the entire history of NASA. This is adjusted, right, for inflation. So $1 20 years ago is kind of equivalent to the dollar we'd be using today. And obviously, you look at that big peak right at the beginning. What's that? Right, the moon program, right? So you can see, in a sense, you can always look at budgets. What I love about looking at budgets is that a dollar spent on NASA is a dollar you don't spend on something else, right? And that's true for anything in the federal government, even though the pot can be kind of arbitrarily large, right? Since the government runs a deficit every year, we don't have, it's not a purely zero-sum game, But at the end of the day, the money you spend on one program, you can't spend on another, right? And so that then says that when you look at what is spent and what is proposed, even to be spent, you see it as a proxy for political priority. And the amount of money going into something, again, kind of reflects the overall public interest or political support for something. It's not perfectly one-to-one, but it's a way to kind of interpret that. And so you can look at this very clearly in an inflation-adjusted way. When did NASA have the most public support, right? The answer is pretty obvious looking at this. It's when you got that big jump up in NASA's budget for the Apollo program. Apollo program clearly tells us another thing, right? That the political will or the political support for that program didn't last, right? Because it falls almost as quickly. And that's a lesson, right, in terms of how you build or don't build an enduring political coalition. And then you see after the collapse, NASA is actually relatively stable in terms of how much money it has gotten every year since, if you adjust for inflation. It's around $20 billion a year. And that's kind of an interesting, despite different presidents, despite different Congresses, despite wildly different, global technological context, right, from the 70s to now. You have this bump in the middle. That's basically your International Space Station funding coming in there. And of course, when most of that work had been done, it kind of goes back down to this weird baseline. And it's like there's no one arguing every year for a baseline of 20 billion. It just kind of tends to happen that way. So that's something just to keep in mind, that all of these things we can do in the universe, exploring, sending people places, the investments we make in space science research, right, and RNA funding. NASA funds something like in the order of $1 billion of direct grants a year. That's all wrapped up in this $20-ish billion. And you've seen a little bit of a recent growth for that in the last few years, which has really helped. But again, compared to what it's been in the past, it's relatively modest. So that suggests that there's room to grow from a political perspective. And then just to put things in context, classic thing, right? You see this, NASA's half a percentage of the overall expenditures in the federal government. This just puts it in the context of, when people say, if someone ever comes up to you and says, why are we spending all this money on Mars rovers when we could be doing X, Y, and Z? It's like, well, we do the X, Y, and Z. Like, we actually spend pennies, if that, on what we spend on space. And you can see here the blue spending is what's called mandatory programs. It's how much the government automatically pays based on laws set in the past. And that's completely dominated by Social Security, Medicare, Medicaid, interest payments, and a few other things. The orange stuff is what Congress decides to spend every year. That's called discretionary spending. And so whenever you see people in politics arguing about, should they set spending, how much, $1 trillion this year or not, that's all just the orange part. It's roughly a third of the overall federal spending. And so you can see how serious members of Congress are about controlling spending, if that's like their thing, whether or not they're attacking the blue part or they're just focusing on the orange part, right? So kind of good proxy for how serious they are. Notice one extra thing in this orange part, right? This discretionary spending that Congress actually decides to spend every year. Roughly half of that goes into defense, right? The Department of Defense. So that's on the order of, between friends, I think $700 billion a year, $750 billion a year. Everything else the government does, from the Department of Transportation to Department of Commerce to NASA to the National Science Foundation, National Institutes of Health, that's in that last little orange wedge of which NASA is part. That's called non-defense discretionary spending for those who like acronyms, NDD. And so you can see this tiny little wedge of about 13% of all government spending is focused on things like NASA. And this is why you hear people say that the US government is basically an insurance program with the military, right, in terms of what you're spending things on. And of course, it gets more complicated. NASA's not just 0.5%, right? Within NASA, money is divvied up in different ways. And so you don't just have that $20-ish billion a year to spend on whatever you want. It all gets very precisely ordered and placed in various aspects of its responsibilities, right? And NASA's portfolio of responsibilities has grown over the years compared to the early 1960s when it was very much focused on the moon. Now you do a lot more, right? Everything from aeronautics to planetary exploration to heliophysics, to technology development, research, and all these other aspects. And so there's that top line number, even if you can't grow that much, how you distribute the internal funds can actually make a huge difference in terms of the types of missions and research and investments that the space agency makes. A lot of you probably are interested in, I tend to focus on planetary science because that's really our wheelhouse here at the Planetary Society. A lot of you are probably interested in that. So I'm going to talk about it in a little bit of an example, but it's going to be a similar story for any one of the 4 science mission directorates at NASA. This is the history of planetary funding. Again, adjusted for inflation at NASA, you can see it's dominated by, and this is kind of similar for a lot of sciences who go in and out of vogue in a sense over the years. Planetary being anything sent to a celestial body, not that's not focused on the sun, and it's not kind of pointing back on Earth, right? So anything to the moon, anything to Mars, anything outer planets, asteroids, so forth, that would be a planetary mission. And you see it's dominated by these peaks, right? Again, you can use this as a proxy of political interest. First peak there is the moon program, so all the lunar robotic missions. Second peak there, it's Viking, actually just the Viking missions. Those are like the Cadillac missions of all planetary missions. And then planetary was out of vogue for a long time, and it's actually been kind of slowly crawling back. And when I came into the Planetary Society in the early 2010s, planetary was on this kind of decline. And this is kind of around the point after Curiosity, but really kind of before Perseverance kind of came in, and there's this big question about the future of the program because the budgets had been falling. So there wasn't enough money to pursue future flagship missions and keep the current set of missions and try to keep smaller active missions to other parts of the solar system. So it was in a real bad place, really, this kind of declining funding and again, being out of vogue and not getting the kind of political support it really needed to address the priorities of the scientific community. And this is keep this in mind, I think, as we talk about like whether or not this kind of advocacy is effective. So this plot is this is the setup as it was in the early 2010s. Another issue for space projects, and this is something I think it's really important to remind ourselves by. The number I really want you to focus on is that top line and part of this chart. And this is wage growth, right, over the years. Why is it hard to save money on space projects? Why is it hard to make them cheaper? If you look at the history of funding and costs of planetary missions, for example, any NASA mission is like this, you'll notice that missions like Mariner back in the early 1960s or Viking in the 70s, really not that much different in terms of scale of cost than the missions we're doing now, right? Billion-ish dollars, plus or minus a few $100 million, depending on how complex it is. And if you think about that, that's pretty wild. Like the type of technology that we had in 1970, wildly different and less efficient than the type of technology that we have now. So why do missions still cost billions of dollars like Perseverance did? Well, the majority of work on these missions, right? There's no assembly lines stamping out Mars rovers, right? Every spacecraft made, particularly in the science spacecraft, it's this kind of boutique handmade item. And so that's made by people. And so the costs of space missions are actually dominated by wages, the cost of wages. And if you look here, this point is of this top chart, people with advanced degrees, or even people with bachelor's degrees, these are adjusted. You notice up here, these are adjusted for inflation, right? So this is actual growth over the years. The cost of paying people with advanced degrees has just gone up. Wages outpace inflation. So you have any project that requires a lot of engineers, scientists, managers to pull off, that project has gotten more expensive over time just because of the people involved. So you either have to drastically limit the number of people you have, but it's hard to do in government projects where kind of this is one of the selling points is giving people jobs. And so the cost of missions stays high as a function of the cost of paying highly skilled people. So my point here is that when you're looking at these missions and the budgets go down, there's not a lot of efficiencies you can do, right? Unless you fire lots of people, but then how many perseverances can you make with half the staff? It's not really clear. And so there's this fundamental problem. There's just a limit. So why this is kind of, let me get to this. The answer then is really, there isn't like a policy trick that you can pull off to just make missions cheaper. We can talk about maybe some options in the future, but very different types of missions. It's really just the fundamental answer when budgets are small and you have a lot of missions ideas to do. You really just need a bigger budget. right? That's the outcome. So that's ultimately the direction that we're going to be pushing in terms of policy at the federal level, because of that issue with wage growth and the complexity of these missions maintains high. This is something I like to show to graduate students and other career scientists like yourself. And again, sorry for all these charts that may be a little complicated at first. This is from a survey from the National Science Foundation of recent PhD of doctorate recipients. And this is a percentage of them who have a job offer at the end of their doctorate. So after getting their doctorate, do you have a real job offer within the next month or so? This stuff really impacts you, right? And so notice that this is a downward trend from the early 2000s, that on average, PhD recipients have had fewer job offers. And look at this in the green, the physical sciences and the earth sciences, a kind of a huge, from 70 down to nearly 60% in its nadir in the mid 2010s. This tracks with overall government spending on domestic, and that the kind of orange part of government spending. Science spending is very rarely bucks the overall spending trends in the US government. It's only about 10-ish% of that discretionary spending amount overall for every type of science, including medicine, biology, you name it. So this has a real world impact on your job prospects. When federal investment in science goes down, you have fewer jobs to choose from, and fewer of you will get jobs as a function of that. And you can see some changes here. Mathematics and computer sciences are kind of exceptions here in the orange, obviously because there's a huge private sector component. But for those of you who are doing pure R&D or basic research and development, you're very much reliant on federal investment. So this is my pitch to you for relevance. Why should you care about this stuff? Well, your very future career may depend on it. So care about this stuff. Okay, so let's check my time here. Now, okay, we have this problem. We need to get more resources for this type of work. Where do you go to do that? Well, this is public funding of research and development, right? So we have framework for this, and we have representative democracy that is set up to do this. And we can debate the exact, the range of how representative this democracy is, but it can be quite effective for the people who play in the system. And the representation is kind of done as a function of how much people are, in a sense, noticed by that system or participate in that system. And so participatory aspect of this is really important for effective representation, particularly for people like scientists. This is not something that I'm just saying as a kind of a pointless exercise. Like, this is something that organizations spend a lot of money to do, is to go and talk to Congress. So this is I show this example. This is from Space Exploration Technologies. This is SpaceX, right? This is their annual formal lobbying expenditures that they're required by law to report, right? So this private company spends now, you can see they've ramped up their spending. They've almost increased it by a factor of 10 over the last decade to lobby people in government, right? And, they would not do this if it didn't work, right? They wouldn't just spend this money for no reason. This is mirrored by all the big aerospace companies, Lockheed, Boeing, Northrop Grumman, you name them. Universities too, again, have various expenditures for this. Now, what I always find actually kind of fascinating about this is how little they're spending. Look at that, it's only at $2-ish million a year. That's a steal if you get policy change to help you get a $50 billion contract. And so there's actually debate in economist circles about why there's so little lobbying, whether it's by organizations with a skin in the game or even nonprofits like us at the Planetary Society or professional scientific organizations. So we can talk about that if you'd like. Anyway, I'm just saying that there's worthwhile, you can look, people do this for a reason because it works. So this very advanced chart that I've made here about how Congress who is influencing Congress. Obviously, they're in this area, two big interests, obviously, the space community, space companies, and then, of course, they listen to their constituents. NASA itself, it's important to remember, is told what to do by a bunch of different people. So there's no single answer about how to influence policy here. Always good to remind you all, NASA is part of the executive branch, right? So the president is kind of like NASA's boss. They have to do what the White House says. Any NASA policy is White House policy. And that can be changed ultimately by Congress through two types of legislation. Authorization bills, which basically set NASA policies and directions and focus, and then appropriations bills, which is what we tend to focus on, which are annual. They have to pass every year in order for the government to stay open, right? When the government shuts down, that means there hasn't been an appropriations bill. It's a law authorizing transfers from the US Treasury for specific purposes of federal agencies. A lot of policy gets written in this appropriation bill every year. And that's kind of, again, what drives the ultimate amount of how much resources NASA has to work with. NASA also takes input from the National Academies of Sciences, Engineering, and Medicine through the decadal survey process and other formal advisory bodies. And then they also have a NASA Advisory Council, which is kind of optional. But the point is that they're having a lot of people telling them what to do, right? And so when this is all in phase, all working together, NASA can actually move pretty sprightly and put resources to something and get a lot done. When they're all out of phase and disjointed or at odds with each other, that's when you get a big mess. And so the more we can kind of align the players in this to agree on priorities, in a sense, more efficient NASA is going to be, the more effective NASA is going to be. But if you don't like something NASA is doing, or you think, why is NASA wasting money in this? Why is it doing this? It's probably because one of these points of input made a very strong stand at one point, and they have to, by law. So NASA administrator is not an independent actor, right? They have to do what they're told by both Congress and through the White House. Also important to remember, it's maybe you can consider this an advantage. Public attitudes about space do not drive investments in space, right? We think Apollo is great now, obviously, and it is great, I think objectively. But this green line, this is a public polling during Apollo through the 1960s. People kind of liked it, but whether they thought it was worth the cost was very mixed. See this green line here. It only ever peaked above 50%, basically right after Apollo 11, right after Neil Armstrong first walked on the moon, right? And it was dropping after. And so that's part of that reason, I think, why Apollo fell very quickly in terms of budget priority, because the public didn't think it was worth the cost. And then this other thing, how much are we spending too much on space, was a growing trending thing at the end of the 1960s and early 1970s. And so we forget that Apollo was not like super popular while it was happening, right? A lot of people felt it wasn't worth the cost. It wasn't worth the priorities we were putting into it, even if now it's kind of entered this kind of mythic status. And this is the case when people do public polling of the nation. This is from 2 years ago. We actually just had a poll yesterday that basically reproduced this almost exactly. They asked slightly different questions, but the outcome was roughly the same. If you just ask people what aspect of what NASA should be doing with its priority, usually at the very top, it's monitor Earth climate and also monitor planet, for things that could hit us, planetary defense. Then do some science. Know what's at the very bottom of this, right? No one thinks it's very important if we send astronauts anywhere, to the moon or Mars. But if you wanted to co-plot this with how much money we're spending on various programs, we would almost invert this, right? Sending astronauts to the moon is roughly we're spending on the order of $8 billion a year now. And Earth's climate, we're spending about $2 billion. Monitor asteroids, we're spending like $150 million, right? So it's like almost anti-correlated in terms of what the public thinks is important and then what politics thinks is important. And I think it's because, again, there's a very low level of political engagement on space, which, if you are going to engage on space, makes a huge opportunity for you to help direct this, because you're not competing with a bunch of other voices on this. So targeted citizen advocacy can really improve this. I have data to support this. This is from a poll of congressional staff, senior congressional staff, saying, if your boss is undecided on something, right, it's a non-ideological issue that they're undecided on, how influential is various forms of constituent representation, communication in terms of changing your boss's outcome? And it's kind of in-person visits, telling them what you think, individualized letters, individualized phone calls. This kind of scales with the amount of time you put into it. If they see more of your time coming into it to talk about an issue, they probably see you as kind of a tip of some iceberg. And again, this keyword here is constituents. This only works if their political future depends on your vote. And that's something important we can talk about here in a minute. So if we want to be more effective space advocates, we just need to use some of the public to engage, I'd say, key members of Congress. So there's no, it's not really super partisan. There's no organized opposition. So we just need to get some key members developed to be space supporters, and we can make quite a bit of impact. We're flowing through a lot of this, so should I just pause for questions right now before we get to the 45-minute mark? Does anyone have any questions they want to ask at this point?
Sure, yeah, folks, if you have a question for Casey, just go ahead and unmute, or you can throw it in the chat.
If not, I can keep going.
I was just going to say, Casey, so one of the things I noticed in the budget, in the kind of peaks and valleys, was actually, I wanted to point that out, and I pointed out in the chat, but if in that spot, in addition to, you could see the bump from ISS, you could actually kind of see at the end of the president's budget when the planetary community started to organize and the top line for NASA started to go up. And I wanted to really highlight that, because that was done by coordination of multiple groups of people. So the Planetary Society started to do some really good advocacy and started writing pieces and doing the kinds of things that an organization is like that is really good at doing. And then the professional societies also got involved. It was really a neat time. It was kind of scary because our budget had just been hugely cut. They had cut they had significantly cut out
in 1 year.
Yeah, so it was amazing.
I'll circle back to the end of that story, and I have an updated chart we can show the outcome of that work.
Well, I was just going to say that a lot of the advocacy that was done then was actually done by people who were grad students and postdocs. I was a postdoc at the time. It was a big part of the DPS was grad students going to Congress. And so it's a really important little bump. So I'm glad you're going to focus on it later, but I thought I'd just, folks that are really interested in how they can have an impact, then that's a really good thing. Are there any other questions for kids at this point?
Hi, I have a question. I'm Elizabeth. I'm one of Brittany's students. Looking at all these things, it seems sort of like the motivations for support of NASA, but then also for funding for NASA, are like pretty complicated and maybe not as intuitive as it would seem. How do you kind of look at these different motivations of why people support NASA versus want to fund NASA, and kind of decide on what strategies to use? Because there's all these different strategies, and I would say, like, if you went up to someone and be like, why do you like NASA? They're like, astronauts are cool, moon is cool. But then if you look at these, it's like almost completely opposite. So it's sort of, I feel like it's not intuitive.
Right. Great question. And I think it is a complicated answer. And I'd say there's a difference between asking the question of what do you like about NASA versus kind of what people will go to bat for in the political level, right? So that's, in a sense, this is kind of the perennial problem in Congress. There's no one against NASA pretty much in Congress, but whether they will make much of an effort to stop, cuts to a program, totally different question. Right. And so it's kind of, how do you build NASA or various aspects of it into a priority point for them? And I think the answer then, is generally it's going to be kind of dependent on the member of Congress, because they're all somewhat idiosyncratic on this issue. And a lot of it, I'd say probably the easiest issue is the parochial relevance, right? So we step back. Why don't I just jump forward, because this is somewhat relevant to this, which is there's one thing that members of Congress want more than anything else, right? And it's to be reelected. And so they're always running for reelection, particularly in the House, where you have every 2 years, you never stop running for reelection. Reelection, obviously, it's the people in your district who vote for you. And so it tends to be, in the mind of a member of Congress, there's a strong correlation between the economic kind of attitude, positive economic attitude, and whether they get reelected. Obviously, it can be more complicated than that, particularly nowadays with increasing just really intense ideological divisions. But generally, if you have jobs, good jobs, where people feel like there's good economic conditions, they'll be happy with their member of Congress. And so the easiest and kind of first step that we tend to recommend when reaching out, particularly to a new member of Congress, is can you find a local footprint from NASA or some NASA project in that district that is feeding into some economic benefit, right? And then you don't have to be really into space. You don't have to love rockets. You don't have to be, look at the stars and be filled with a sense of awe and wonder. You just have to have cold, hard kind of like, is this doing good for my district immediately for people, right? And this is kind of an argument that I make, that this kind of practical argument and a political point, every other industry, that's their opening argument about how many jobs are being created in that district. And so this is something I think, and this can be graduate students, summer students, undergraduate students that have summer stipends to work, in a research lab on a NASA project, as opposed to working at the grocery store or something like that. And these are real impacts that are being made and jobs being made. And similar to that, if you can find kind of the interest of those particular representatives and align NASA with those interests. They have an interest in workforce, high-skilled manufacturing. Do they have an interest in STEM or mentorships? Do they have an interest in international relationships? And NASA is actually broad enough. You can have it kind of apply and fit into their various areas of interest. And that's kind of this, in a sense, doing your homework with the person you're communicating with, right? So the easy thing about this, it sounds like, oh man, that's like so many people to figure out. But as a constituent, you only have 3 people to worry about, right? You're 1 member of Congress and 2 senators. And so if you can do a little bit of homework on who those people are, what their interests are, and what they've done in the past, you can help kind of tailor your message and kind of fight. What I have here is this, like, you have to kind of fight for a beachhead in their mind by staying engaged on it, right? So the congressional mind is kind of dominated by these really big hot button issues. And space has to fit in somewhere, right? And you fit in just by showing up, because everyone's kind of cognitive shortcuts are, if I can't easily recall something about a topic, it must not that be important, right? And that's a fallacy, but that's how our brains work. And so, if they don't hear from their constituents about issues in space ever, then they'll just assume it's not very important to them. And this can be 1 person or 10 people writing every couple of weeks, or 10 people writing once a month. And suddenly their office starts to collect and notice, like, hey, this is an issue that we care about. There's things here happening that we care about. There's NASA money flowing into these, small businesses and so forth that we care about. I was just reading here, I live in Washington State. The governor is going to meet with a 12-person, head of a 12-person company that creates carbon composite tubes that happen to be contracted with JPL to give the landing legs for the Ingenuity helicopter. That's a 12-person company doing 1 order for JPL, and they're going to get to meet with the governor now, right? Because that's the kind of connection. Like, suddenly there's this very local connection making a very discrete and specific economic impact for something big and exciting. And so I think the key is finding ways to connect these abstract ideas with very local, parochial benefits. And that just takes a little bit of homework. Does that answer your question? That was kind of a long answer, but I think I hit parts of it.
Yeah, it does.
Great.
And Casey, before you go on, there was another good question from someone that doesn't have a mic. And he said it would be interesting to get Casey's comments about what the public find interesting and exciting about basic science and space science.
Yeah, and so I think, again, so I'll always kind of turn to this. Divining what the public likes and doesn't is kind of a dark art, and I think it's hard to know exactly, right? And I think that it's a function of that. The way that I interpret this type of result, and again, we saw this just come out again, another one this week, is that most people probably don't think about things very much in space. And when presented with so you get a phone call from these people, they present you with these options, and you say, oh, that sounds important. No, that's not a high important. Probably this is the first time they're thinking about it. And so you can kind of see a correlation of what is the most seemingly relevant to them, right? So how is space relevant? Oh yeah, monitor Earth climate and like I live on Earth. That seems really important to do. That's like a high priority. Oh, I don't want to be hit by an asteroid, right? No one's against that. That seems really important. And then Mars and Moon sound very abstract and like, what is that? What's the point of that? that's kind of how I interpret this, because there tends to be in broad public a general, I mean, it's just a lack of awareness, but also just uncertainty. How all of this works is very abstract. And I think, but to generalize, right? I think there is what people respond to, and I think what we saw again this week, they respond to ambition. They respond to taking risks, and I think we've seen that with like the way that people respond to places like SpaceX that are willing to fail publicly. But also fundamentally, they respond to like success, right? So if you can do something and do it well, people can get really excited about that, right? And you're doing something new and something different, and people will resonate with that, because the one thing that kind of NASA has that is hard to measure, but I think is real, is it's kind of the only government agencies whose job is to like, really at the end of the day is like, hey, go out and make us proud, right? The actual scope of NASA is kind of insane for a government agency. It's like its job is to just like, hey, do some cool stuff. And to do that well, and people really, I think, can resonate with it and feel really good about it. And it's a rare bit of kind of optimistic, fundamentally optimistic activity that we do. And so I think that it's kind of this mixed thing. And I think people also just tend not to understand how much we spend or don't spend on NASA, right? Because the name of space missions tend to be like this like composite word with their cost, right? So it's not the Perseverance rover, it's the $2.7 billion Perseverance rover. And you don't do that with like roads. If you don't drive the like $10.2 billion I-5, up and down the West Coast, right? It's just, people don't have that kind of same relationship to other government things that actually cost, and we spend a lot more on. And so because of NASA's, I think there's this kind of mix, and it's, I guess by how I'm answering this, it's a hard problem to really fundamentally solve. And in a sense, this is kind of why I avoid it. In convincing the public is a really hard, very big generational project that I think we should work on, right? Don't get me wrong. But I think you can kind of short circuit that by focusing on, again, these key members of Congress. Because my whole point earlier was that what we spend on, like, again, looking at this, does not correlate with what the public support is, right? And so public support isn't what we need to drive investments. We need to cultivate political support. And that is through, again, this kind of ongoing advocacy for your own, ideally in the sense that kind of for your own science, for your own activities. And then if you want to do, through your professional societies, through organizations like the Planetary Society, of promoting what you care about. And then you don't have to convince, we live in a country of 350 million people, like that's a lot of people to convince, but you just need to convince some of them and you can still get really good outcomes. So I'll let that, feel free to chat a follow-up question to that if I didn't answer that well or to your satisfaction. I'm just checking my time here. All right, so some people, I just want a few kind of practical things. First, if you want to get more details about how to be an effective space advocate, I do have a free online course. It's pre-recorded, you take it at your own time at courses.planetary.org called Space Advocacy 101. It walks you through very detailed, like how government budgeting works for space, how to think about how to find and interpret contracts that are spent by NASA in your district, how to find money that NASA spends in your district, and also basic communication strategies for your member of Congress. And again, I kind of really sum that up as like, do some basic research on them. Do they serve on a relevant committee? Committees here being the ones that basically write NASA's laws and fund NASA on a year-to-year basis. If your member of Congress is on one of these committees, they're a super member of Congress and they have outsized influence on the direction of NASA. If they don't, then it's a little harder, but you should still be talking to them. So if you can do your research on your member of Congress, Google any statement, like Google their name and NASA, see have they ever said anything about NASA. Some of them are secret NASA fans. I had my member of Congress up here just outside of Seattle, no big NASA presence in his district. First time we talked to him about NASA, he was like lit up and like whipped out his phone and showed a picture of Curiosity landing as taken by the HiRISE imager on MRO. And he just had that, right? And he just like, oh, I never had a reason to think about Mars in this district before. Now, my wife is a Mars scientist here. She's like, now I do. So you never know, right? So you can do your research and communicate to them and connect with them. And then you can kind of pitch the validity, the local benefits of NASA. You can talk about, what their interests are and how your work either aligns with that or could align with that. You can just talk about, just even showing up and saying, hey, I exist, I'm a scientist in your district, I depend on NASA funds. That makes it relevant, right? Suddenly, this abstract space program is actually providing for funding for students, funding for your research, maybe funding for university, and they may not have known that. And it's an ongoing thing. Staff cycles out all the time in members of Congress's offices, so you should be communicating on a semi-regular basis and be known by them. And if you don't do that, someone else will probably be talking to them about maybe space, and you have no idea what they're going to say. You don't know if they like it or don't, and that'll be their impression of space, right, from their constituents. So if you don't do this, right, you functionally don't exist to them. If you opt out of the system, there's no way they're going to seek you out and ask you about space or space science or whatever aspect of science research or funding you want. This is a participatory system, and if you don't do it, then there's no, you're kind of muted.
Really quick, I was going to just add to your story because you were talking about Congress people that didn't necessarily know they had members in an area or had constituents. I made a point in the chat, which if people aren't looking at the chat, is that the fact that organizations like TPS have members everywhere, and then the Planetary Society or the Planetary Science Institute in places that are like virtual institutes has really helped because there are employees distributed across the country. So that's been a shift also in the last 10 years, at least, to more scientists doing that. But I was going to share kind of a similar story is that actually one of the biggest advocates for planetary science in the last 30 years was a congressman from Texas who you'd think was actually, at Johnson or something like that, but he actually represented an area that was outside of that and maybe had some Johnson employees, but it wasn't actually, it was a passion project for him. He really cared about it. He loved Europa. He thought JPL was amazing. And he, even though it didn't go into his district at all, he was the biggest advocate we had for a long time. And he, despite political differences, he was one of those members. So I thought your story about, just how much the Congress members don't necessarily either have the personal connection or on the other side, develop a personal connection. There's both sides of that coin for sure.
Right. And also to the point of how much influence he didn't that particular member, John Culberson, is basically why we have the Europa Clipper today. He started giving NASA, mandating them tens of millions, hundreds of millions of dollars on that mission before NASA even officially said that they wanted it. And you didn't need to convince 300 million people and have a popular uprising demanding the Europa Clipper. You need to convince that one guy. And he had the influence and he went to bat for that year after year. And now we have the Europa Clipper, right? And so that's the possibility. So finding people like that, maybe your member of Congress is a secret space fanatic who doesn't know they love it yet until they talk to you, right? Pulling this out and giving them a sense of connection and excitement and understanding the opportunities is one aspect of, I think, of being an advocate that's really important. Real quick, I just want to plug here, this as a picture. The Planetary Society has also tried to do a lot of work over the years of building larger coalitions, particularly for planetary science. This is the start of our Planetary Science Caucus, kind of this informal, semi-formal group of members of Congress who kind of raise their hand and say, yes, I'm really interested in planetary exploration. And so building a set of people who are already saying that they're interested in this topic is a really good thing. This is the start of the caucus. The Planetary Society, pre-COVID era, also organizes in-person visits to Congress every year. We've had over 100 people come on their own dime from 28 states in the union, flying to DC all to be together to do in-person advocacy, right? That top most valuable action you can do as stated by congressional staff. So that's something we've done. We're doing a virtual one this year, obviously. And again, just to show this can work, as Brittany mentioned, we did a lot of work and also working with the planetary community and the professional scientific communities to really push back for NASA planetary funding. And here's the result in the rest of that year, right? So after 30% cuts that had been coming down the line and more cuts proposed by the White House, we actually got planetary science up to historical highs. And it's actually staying around that right now. A really incredible turnaround that happen because of engaged and ongoing political advocacy from the community, from supporters of the community like the Planetary Society and from professional society. So this works, right? And we didn't have to cut earth science, we didn't have to cut astrophysics. This came as an additive to NASA because money is pretty fungible at the top level of government funding. And now we have multiple flagship missions. We have all sorts of new missions in the pipeline. Really exciting time for planetary science you would not have predicted 8 years ago. So again, I just kind of want to leave you with this couple takeaways here, which is, again, space is a huge opportunity for advocacy. It has a set of fundamental and unique set of circumstances that really allows basic advocacy to be way more effective than other highly ideological areas. It's underrepresented and otherwise dominated by special interests. And so you as an individual as your science or as part of a planetary society or professional society like the AAS has a huge opportunity to be a counterweight to that. And then I think also members of Congress and their staff, they operate on, you have to compete for their mind share. And you do that by staying in communication with that office, right? Reaching out to them, making yourself known to them, reaching out to their district offices, offering communication help, and then just kind of being around for these things to make that issue present in their minds. If they're not aware of you, they're not going to go to bat for you. And so you have to participate in that system if you want to have that system produce this outcome. So I'll do one more plug. I do have a podcast, because who doesn't these days? Space Policy Edition is a monthly podcast. And I talk a lot about this in depth and a lot of aspects of space policy. That's free. You can find it in all the normal aspects. It's also, if you just listen to Planetary Radio, our weekly podcast, it's monthly on that as well. So you can find me there. At this point, we'll open up to any questions.